What is the proper method for scanning a two-piece scan body?
This is a last question for this month. Kevin tried scanning with a true Ottoman scan post, but the scan cap would disappear when he stopped scanner. He had never encountered this with any other product, so he wanted to know what was going on here. As we can see from the scan imaging, he has great scanning technique. I was not sure myself why that happened when I first saw this, and I didn't even know what that product was. What you do know is that there should be an additional component connected to this metal scan body, but it was not captured by the scanner. So today, we want to address how to properly scan this kind of product. After Google search, we found that the product in question has a plastic cap placed over a metal-based scan body. I believe that it serves as a kind of hybrid scan body where the metal base provides a more accurate scan result and the plastic cap makes scanning more convenient. But the issue is that when trying to scan the cap part, it is automatically erased, so Kevin is wondering what is causing this. And Kevin mentioned a lime green scan cap, but based on what I saw on Google, it appeared closer to what I think looks like an ivory colored Spartan helmet. The shape of the cap appears to be quite complex, and the more complex it is, the easier it is to scan. So it's either that it's not being captured properly, or in this case, just disappears. A user suggests that it may have been caused by the smart color filtering function, but Kevin assured us that the color filtering option was turned off. Chen, have you ever experienced something like this?
Yes, I have. Not with a flash cap, but when directly scanning the metal scan body with a minimal exposure. In the case, I think the scanner would identify that part of the scan body to filter out as an artifact or noise because of the small exposure.
Oh, I see. You suspect the issue may be related to Smart Scan filtering mode, which selectively captures pink and white color to distinguish between gums and teeth. So now I wonder, if the other parts are locked and the filtering mode is set to unlimited, would the cap not be deleted? Or could it be that there are other filtering options that we need to adjust or turn off? This is something I tend to test. Fortunately, I have a very similar product to experiment with. Let's watch a solution video.
There are many different kinds of scan bodies. This image, which many of you have likely seen before, explains that scan bodies can be classified based on the body and base sections. In particular, for the accuracy of the connection area, scan bodies with a metal base are preferred, and with the improvement in scanner performance, full metal scan bodies are more widely used today. Despite the availability of these different designs, one common desire among our users is for scan bodies to have a more complex form that would be more advantageous for scanner recognition. Unfortunately, due to patent issues, the ideal scan body design that users are looking for is hard to find. In situations like this, using a cylindrical scan body with a typical D-cut can lead to unexpected results. When the implant is placed deeply and you don't have a scan body with sufficient length, the critical features of the scan body needed for recognition are not fully exposed above the gingiva. Having a more ideal shape exposed above the gums would make the scanning process easier. The AI matching function can sometimes successfully compensate for the alignment process in this situation. But even with help of AI, if we don't have enough data points for scan body alignment, deviation can still occur, leading to concerns about the accuracy and reliability of the scan. In challenging cases, like in the previous example, several ideas have come up to improve the overall ease and accuracy by changing scan body design. One approach is to design the scan body in a two-piece configuration. This allows for better control and adaptability in various clinical situations, especially when dealing with deep implant placements, improving the overall scan quality and ensuring more precise data capture. Now let's look back at the specific product he used in his scan. The advantage of a two-piece scan body design is that when the exposed portion of a metal scan body is too small to be accurately scanned, it shifts the scan target above the gingiva. Scanning a peak material cap is much easier, and since the alignment is later done using key points, it's sufficient to scan only the decut portion. Typically, the library allows for alignment in both the metal state and with the scan cap attached, so you can choose the approach based on the surrounding gingival conditions. If the scan body is long enough, you can scan it in its metal state. If it's too short, you can attach the cap and scan it in that state. This is why Dr. Zhang calls it a hybrid-type scan body. This is similar to the concept of a hybrid car, offering flexibility depending on the situation. In theory, the hybrid-type scan body should have worked perfectly for this situation. He set up the scan body to overcome the exposure issue, and we would have done the same thing. So what happened? Both Dr. Zhang and Medity team thought that this was unusual, so they discussed possible reasons for this. Dr. Zhang's thoughts were that locking the area around the scan body could have helped in this case, ensuring the scanner would be more focused on the target. Medit hypothesizes that the issue could be due to the scan cap not being large enough. This may cause the appearance of the plastic cap floating above the metal, leading the scanner to interpret it as an artifact, which is automatically deleted. This process is called small cluster filtering, a built-in feature of the scanning software. While this filtering is weaker during the scan body stage, allowing the scan body to remain intact, it becomes more aggressive during the arch scan stage, resulting in the automatic deletion of parts that appear as floating artifacts. So we reached out to this user, asking him what his protocol was. Interestingly, he reported that when he used the scan body stage mode, the automatic deletion did not occur. It only occurred in the arch scan mode. So this leads us to believe that our theory was correct. Then how can we reliably scan a hybrid-type scan body? As we always emphasize, providing the scanner with preset information is crucial. If you're using a hybrid-type scan body, it's essential to always register it and utilize AI matching for optimal results. Moreover, by doing this, we can verify that the scan data is properly obtained and aligned. We conducted an experiment with a similar product. This dentiform model simulates the scenario immediately after an extraction and immediate implant placement. Following our scan strategy, instead of trying to scan the gingival area or the metal pillar, we pre-registered the scan cap shape and attempted AI matching. The result was successful. Upon reaching the matching point after scanning from an adjacent tooth, the scanning software immediately recognized it and performed AI matching. This highlights how utilizing Medit's software features can make the scanning process much smoother. Let's not forget that these strong features can greatly enhance our workflow efficiency. In this question, we analyzed the scanning method for hybrid-type scan bodies. Today, we learned that a new type of scan body does not necessarily require a special scanning technique. By following the general rules for scanning scan bodies, you can proceed with the scan using the same workflow without any issues. If you are having difficulties with the implant scanning process, we recommend trying to use these hybrid-type scan bodies. This concludes the answer to question number 4.
This wraps up today's webinar. Thank you for being here. We hope to see you next time. Thank you.
Thank you.